Hi everyone, my name is Braden Woodard and my presentation is regarding the history of internet coverage. Very exciting stuff, but as consumers and technology students, we should know the history and information regarding each major internet connection development. I chose this subject because when I was shopping for internet, there were a few options at the top of my list. Cable from Cox, satellite from Viasat, DSL from CenturyLink. So what did this all mean? Well, let's figure it out. So how do we connect to the internet? Of course, we're already doing it as you're watching my video, but let's take a look to see the few steps. So step one, you need your access device, which is usually a smartphone, laptop, tablet, wearable device, anything that'll connect to the internet. Then you need a connection, which is what we'll focus on in this presentation. Internet service provider, and then the internet. So the connection types that we have are dial-up, DSL, cable, fiber optics, wireless, mobile broadband, satellite. We'll step into each one of these in more detail. And if you guys haven't heard of ISP, that's your internet service provider. So if we look at the nationwide map here, we could see that if we take a look at Arizona, obviously Cox is the biggest player in the ISP game here. Other ones, notable mentions are Comcast, Verizon, CenturyLink. So, 1989. Dial-up became established as the sole method of accessing the internet. Back at the time where Netflix was incomprehensible, the analog connection max speed of 56 gigabits per second, but usually more like 30 to 40. So just to take that into consideration, that's loading a Google search would take around a minute and a half. That's literally just the results page. So in 2017, 3% of the US population is still using dial-up only, which is mostly rural areas. If you used AOL as a kid, obviously you remember the good old sound of isn't that nice? But if I remember having to tell everyone at home, hey, don't get on the phone. If not, you're gonna kick me off the internet. Well, that's exactly how it works. It's a telephone jack. It's connected at one end to a telephone outlet, and the other end is to an internal modem in the computer. That same location has an outlet to the actual home phone. So if someone uses the home phone, you're not able to get on to the internet. So the service is provided over phone lines, and because of that, it's inexpensive. It's usually around $5 to $25 a month. So if we look here, like I said, the computer, the modem, goes to the phone line, which phone lines are coverage everywhere. That's why rural areas are able to access that. So 1993, there was DSL became the new norm for higher speed internet connection. It's still a primary form of connection, available to around 90% of the US today. It was also the first always on connection, which means that it's on 24/7. As soon as your computer is on, it's running. So there's no need for the beeps and the boops like dial up. So how does DSL work? DSL is very similar to dial-up as it uses a traditional phone line, which makes it widely available, of course, and more affordable than cable, fiber, fixed wireless, so on. It uses a DSL filter, and we can see here. Just like dial-up, it connects into the telephone jack, but it uses a DSL filter. One of them goes into the phone nearest to your computer, and the other one goes into your modem, internal modem. Or a modem that you can use to connect your access devices to. The phone line can also be used at the same time as the internet, which was a real breakthrough at that time. There are a few factors that can inhibit the speed as DSL, such as peak use, slowdown, the distance from your home to your ISP, and even storms. Sometimes they call that the rain fade. According to an article by Broadband Now, if we take a look at the difference between the delivery of data transmitted through the cable, we can see that there's significantly, so if we look here, we can see significantly more data being able to be transmitted through the cable compared to the telephone. It's by having a higher frequency band. You can see here of 12 megahertz compared to 4 gigahertz. This allows speeds to easily reach 100 megabytes per second, depending on your ISP. So in 1995, we removed the need for phone lines. So we were able to take back our phone lines and have cable. So according to Broadband Now, over 194 million Americans use cable delivery methods for high-speed internet. And it works by using pretty much the same copper wire that you would use to your TV, which is a coaxial cable. It's now being used to go into a cable splitter and then into your cable modem. It does require a few extra steps. It requires the use of a DOCSIS, which means data over cable service interface specs, which specifies a standard protocol for the cable modem to modulate and demodulate electromagnetic signals on either end of the coax cable. This is because coax cables are usually not meant for bidirectional. They're usually for one-way traffic like TV broadcasting. But this cable is able to reach double the speeds of DSL and can be cost-effective when bundling with TV service. There is also slowdowns during peak uses. Upload speeds, of course, you'll see that downloads are much faster than uploads. And this is susceptible to electromagnetic interference. So fiber optics, really exciting. Fiber optics is this technology. It's become popular due to the recent developments with Google Fiber. Not many people heard about it until Google Fiber started coming out. The fiber optic technology has been around for quite a while, with the first fully optic fiber cable being buried underneath the Pacific Ocean in 1996, which paved the way for faster internet data transmission. Much of the internet backbone is accessed by fiber optic cables, so you'll sometimes hear that there's the internet backbone and then there's the last mile. So the last mile is all the other connections that I've been talking about and we'll talk about are part of the last mile. Fiber optics are the backbone. So that's why you see here in the map, those go undersea. They're called submarine cables, and they actually meet into mainland, and that's right there where your main hubs, ISPs, get their internet from. So it's the fastest form of internet connection technology, and it will not be considered obsolete anytime soon. According to FIS.org, in March 2018, a record has been set in Japan when a 3-mode optical cable with multi-core technology was able to send 159 terabytes per second over 1,045 kilometers. This will be paramount in the data capabilities for the future, such as big data and 5G networking services. This speed is able to reach these speeds due to being able to transmit data through light instead of electricity, which means the frequencies, like we spoke about in DSL, are much higher with greater data capacity. Light is able to be transmitted through these cables because they're made from glass and plastic instead of metal or copper, like coaxial cables and telephone cables. Setbacks from here are just the major installation cost. According to the FCC, it recognizes that the high cost of laying the cable is a substantial barrier to broadband infrastructure. growth in the US, analysts estimate the cost of Google Fiber's nationwide expansion plan to be $3,000 to $8,000 per home. So that's why we're not seeing a huge implementation of the cable system. So if we go to our next step, so fixed wireless. Fixed wireless, it's not Wi-Fi. I thought the same thing. Fixed wireless is a point-to-point connection between your home antenna transmitter and your ISP receiver. Unlike Wi-Fi, fixed wireless cannot go around barriers like walls. It has to have a direct line of sight. So if you see here, a direct line of sight from your antenna to the access point, which, if you think about it, it's kind of just like an invisible wire, which is kind of archaic. But this form of connection uses radio frequency, and it's always on connection. But it has some drawbacks like slower speeds, such as 5 to 50 megabytes per second. But it's used in rural areas that do not have access to DSL or cable. So we're all well aware of mobile broadband. Mobile broadband is nothing new. 2G has been around since 1991. 3G since 2001, 4G 2006, and so on. Our most recent development is 5G in 2018. And like I spoke about, fixed wireless, it's just like that, but it's except your phone is your antenna that transmits and receives the data through radio waves provided by your ISP. This transfers digital data as well as calls. Currently, AT&T and Verizon cover 94% of the U.S., and with 5G infrastructure still being implemented, we will soon see the end of 4G. Though this connection type is very convenient with wireless access, fast speeds, large coverage areas, there are a few setbacks that come with developing tech, such as data caps, I think that we're all struggling with, and new device requirements, such as older devices not being able to handle 5G or LTE. So we have satellite, which is sounds kind of similar to fixed wireless, but it's actually quite different. Satellite internet connection, it sounds pretty advanced, but as a gamer, let me tell you that it's not. Let me explain. In March of 2017, HughesNet launched Gen 5 satellite, which allowed around 25 megabytes per second speed for users, pretty much nationwide. You may think that's pretty fast, but if you think of how far the signal must travel, these satellites are in high orbit, which are usually about 20 to 40,000 miles away from us, which, as a gamer, if you're trying to play, first-person game, shooter game, you'll have a millisecond latency between the transmitter and the satellite receiver, and just that millisecond, you will notice a big difference. So those games are pretty much impossible to play. It does offer slower speeds than the other connections that I talked about, and it also is susceptible to service interruptions due to extreme weather. And also, there's many data caps that can occur with this. So where are we at today? Our future of the internet development are currently coinciding with now. Many things have happened within the last year. We're pretty much at an arms race with low-orbiting satellites. It's between OneWeb, Telesat, SpaceX's Starlink, and even Amazon. So according to Starlink, their plan is to create a 12,000 satellite constellation that'll surround the world. And I don't know if you see the blue here. The blue is where the internet will focus at, and that's where it'll provide. Eventually, they're trying to point that around the whole world. Right now, they are pretty much contracted with just the US and Canada. So if you see...
Phase 1 of the Starlink constellation consists of 1,600 satellites, arranged into 32 orbital planes, with 50 satellites in each plane. Because of the orbits, coverage density is much greater in latitudes near 50 degrees north than it is near the equator.
So if you see, it's kind of like a mesh. They said that because it's in a lower orbit, they'll be able to provide faster speeds with reduced lag. So that'll be great for gamers. Also, it's going to be great for rural and remote users that do not currently have access to other options. So if you see here, I know I just spoke about satellites. This is where they're currently orbiting, and this is where Starlink is proposing to orbit. They currently have released 2 launches. One of them has been in March, and the other one is in November, I believe. Each of them have 60 satellites on board, and OneWeb has also launched 6 satellites in February of last year, and their proposed constellation is 882 satellites. So we're going to be seeing some of that soon. So, what do you guys think? Should we be focusing on implementing faster fiber to home services, or be focusing on worldwide coverage, like from satellites such as SatLink and OneWeb? So, thanks for watching. I hope you guys enjoyed my presentation. Thank you very much.